All right, people. So we are going to do a couple of practice problems using what we just learned on the previous video, right? So how do we calculate the internal energy of a system? Now, before you can solve these problems, an important skill you must have is know, uh, uh, be able to identify in which direction heat is flowing and be able to identify in which direction work is being done. Is work being done on or is work being done by the system? If it is done on the system, it is positive. If it is being done by the system, it is negative. If heat is flowing into the system, it's positive. If heat is flowing out, it is negative. So let's read this problem and let's check it out. So calculate the change in energy for a system undergoing an endothermic process in which 15.6 kilojoules of heat flows, where 1.14 kilojoules of work is done on the system. So we have some important information. We know that it is endothermic. What does endothermic mean? It tells us the flow of heat. Think of the letters En as entering, right? So the heat is entering the system. It's going into the system. So that heat is going to be positive, all right? And it is 15.6 kilojoules of heat. 15.6 kilojoules of heat. Now this 1.4 kilojoules says work is done on the system. So it's going into the system or onto the system. It is positive, right? Remember that the positives and the negatives just have to do with direction. It is not a quantity. It's not more and it's not less. It is just the direction. It's a very important thing to understand. So our delta E is equal to a positive 15.6 kilojoules plus 1.4 kilojoules. Now 15 plus 1 is 16. And the 0.4 plus 0.6 is another 1. So that's 17.0 kilojoules. And there we have it with correct sig figs and everything. I know some of you are going to say, but Mr. Sanchez, there is 2 sig figs. There is 2 sig figs, but when you add and subtract, you only look at one place after the decimal. Okay, so we have, oh, no, we don't, no. So since there's only one place after the decimal, we must have one place after the decimal. If there was 2, we'd have 2. If there was 3, we'd have 3. All right. Now, let's check out a slightly different problem. Okay, it's still the same topic, but now we're going to be focusing on calculating work. So work had its own equation, and one thing you must know about it is that delta. That it's not a triangle. It's called delta. Delta means change. So when you see delta V, you're thinking of the change in volume, and that's demonstrated over here by this figure. It had its initial volume, and then it had its final volume. Well, if you get V final and you subtract it by V naught, its initial, you'll get the change. And that's what we're going to do in this problem. So calculate the work associated with the expansion of a gas from 46 liters to 64 liters. It is always final minus initial. Do not forget that. So 64 liters minus 46 liters. All right, so that's 50 plus another 14. That's 18 liters. 18 liters. All right, at a constant external pressure of 15 atm, not 1.5. All right, so the work is equal to negative P, which is 15 atm. Pretend that's a 5. And then over here we have an 18 liters. All right, so let's check this out. Negative 15 times 18 is like negative 270 or something. 15 times 18. Ooh, I got it right. Negative 270. How did I get that right? This is my 8th time making this video. No. But the units, do not forget your units. It is liters times ATM. But whenever we think of work, we think of joules. This should actually be in joules. How do you turn L times ATM into joules? It's all about Pascal's number. All right. So 1 joule is the same thing as 101.3 liters times ATM. But we'll check that out in the next problem. All right, this one is perfectly fine like this. It doesn't tell you what units to calculate work, it just tells you to calculate work. But if they're more specific, well, you're gonna have to do a little bit more work. All right, let's check this out. And I see delta E, so I'm already thinking delta E is equal to heat plus W. And then I see W, and I always think W is equal to negative P times the change in volume. All right, but let's go and let's read the problem first. A balloon is being inflated to its full extent by heating the air inside it. In the final stages of this process, the volume of the balloon, changes from this to that. Okay, that's already looking like a delta V. So I'm gonna write out my delta V over here. Not red. So our delta V, people, if you ever find, side note, if you ever find a software that's nicer than this, which I'm sure there are, let me know, especially if it's free, because I love free. Free's my favorite thing. 4.50 times 10 to the 6 liters. That is our final volume, and the initial volume was 4.00 times 10 to the 6 liters. And luckily, this is just some mental math. 4.5 minus that point minus that 4 is 0.50 times 10 to the 6 liters. You can only subtract if these are the same, okay? You can't subtract if it's way bigger. You can't just do it like that if it's a much larger number. All right. Well, I mean, you could, but not that easily. All right, so we got our volume. And then it says the volume of the balloon changes from this by the addition of 1.3 times 10 to the 8 joules of energy as heat. And we know heat is Q. So Q is 1.3 times 10 to the 8, and the units are joules. All right, and that's energy as heat. But let's see, is this positive or negative? This is where a mistake can happen. It says the addition, so heat is going into it, so heat is positive. And I write positive to remind me that I already took that into account. If I don't see a positive on there, that means I didn't notice what it was asking for. All right, I know your math teacher tells you don't write positives, and I would agree. But in the beginning, use that as a training wheel until you kind of build up the routine and learn to identify it. So it'll help, trust me. Now, assuming that the balloon expands against a constant pressure, okay, that's a P, a constant pressure of 1.0 ATM. Calculate delta E. Okay, you're asking me directly calculate delta E, and then it says convert between L ATM to joules. Okay, so we want it in joules. We wanted it in joules. Remind me, I'm gonna put a little star. I want joules because I forget. I won't forget because this is my 8th time making this video. That's what I thought, the 7th time. All right, let's check this out. We are not given W. We need W. Well, we are given delta V, and we are given P. So let's do that off to the side. W is equal to a negative P, 1.0 ATM, times, and our change in V was 0.50 times 10 to the 6 liters. Well, 1 times that is going to be the same value. We're just going to have different units now. 0.50 times 10 to the 6, and it's going to be liters times ATM. All right, but we don't want these units. We want joules. So what we're going to do is we're going to take these units and we're going to convert them. We're going to convert them using what they told us. They told us a 1 liter times ATM, 1 liters times ATM. So we're going to put 1L times ATM because the units have to cancel. And then we want joules, so joules goes on top. We put 101.3 right here. And that's going to be like 50 point, no, it's scientific notation, times 0.50 e to the 6. Yeah, it's going to be 50. We'll say 5.1 times 10. Oh, should I round up? No, I'm not going to round. I'm going to round at the very end. Why am I going to round at the very end? I'm going to cut some of these values off at the very end so that I don't accidentally round too much. All right, so that's 3, that's 6, that's 7 decimal places. Okay, so that is our work. And I know it's getting a little bit messy, so I am going to delete this right here. I am going to delete that. I'm going to delete the work equation. And now I'm going to delete this as well. All right, so our work is equal to this. Come back. Uh-oh. Where is that going? Can I put it back together? Humpty Dumpty could be put together back again or whatever. All right, this is still hideous. So our delta E work is equal to negative P. Work is equal to negative P times V. My V was positive. My P was positive. I should have negative work. I messed up with my symbol. All right? But never forget, all right? Don't do what I do. So delta E is equal to Q. So 1.3 times 10 to the 8 plus a negative 5.065 times 10 to the 7th joules. And this one was also in joules. And look at that. Now we can solve this problem all nice and neat. So let's do 1.3 times 10 to the 8, subtract 5.065 times 10 to the 7th, and we get 7.9. 7.9 times 10, and it was times 10, 3, 6, times 10 to the 7 joules. All right, and this right here is our answer. And that is it, people. Sorry for a little bit mess towards the end, and I'm sorry for forgetting my charge, but it's all about making mistakes. It's all about making mistakes, but hopefully a skill you get is to be able to kind of stop yourself and reason with your answers. All right, make sure, always check your positives, always check your negatives, check the direction of the things flowing. Is it flowing in? Is it flowing out? If you can't do that, don't even bother with the equation. Learn to get that skill first and then work your way up. Okay, see you later. If you have any questions, comments, concerns, keep them to yourself. No, let me know, please. And also, if you have any suggestions on how to improve my videos, take them somewhere else, like the comment section. All right, but be nice, don't be rude. Peace out.